Okay, so today we're going to talk about two-dimensional figures, and we're going to begin our discussion with that of a polygon. A polygon is a closed figure formed by a finite or a countable number of sides, with common endpoints and intersections only at their endpoints. Where those sides intersect is what we call a vertex. It's the location of two sides intersecting on our polygon. There are two terms that we can use to describe types of polygons. One is convex. Convex means that there's no vertex inside the polygon, or concave, where at least one vertex is inside the polygon. And you say, well, how do you know whether it's inside or not? Well, if you were to take a pen and you were to connect two vertices, such as these two here, you'll notice that this vertex is now inside that figure. Whereas if we were to do that on this figure, no matter where we drew our lines, we would not be able to have any of our vertices that are inside our figure. So this one here is convex, this one here is concave. Good way to remember that is concave caves in, so this piece right here caved in on my figure. Polygons are named based on the number of sides. Most of you are familiar with triangle, quadrilateral, pentagon. Six-sided figures are called hexagons. Heptagons have 7 sides. Octagon you're likely very familiar with. A 9-sided figure is a nonagon. A decagon, you think of a decade as 10 years. A decagon is 10. A hendecagon is 11. A dodecagon is 12. Anything beyond 12, we use just the number. So for instance, if there's a 16-sided figure, we just call it a 16gon. Those are the easy ones. You do need to memorize these. So let's learn a few more terms to describe polygons. Equilateral, equa meaning equal, lateral meaning to the side. So equilateral, all the sides have the same length. Equiangular means all the angles are the same measure. And then if it's both equilateral and equiangular, we call it a regular figure. So in order for it to be considered regular, it has to be both equilateral and equiangular. So let's try a figure here. I want you to classify this polygon based on the number of sides. I want you to tell me whether it's concave or convex, and whether it's regular or irregular. If we begin by counting the sides, there are 1, 2, 3, 4 sides, which makes this particular figure a quadrilateral. If we connect vertices, we will at no point have the figure that caves in. Therefore, it is considered convex. None of the sides are equal, so that means that it is an irregular figure. Okay, now for this figure, I want you to name it based on the number of sides, state whether it's concave or convex, and whether it's regular or irregular. All right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, which makes this figure a nonagon. If we were to connect, let's just say this vertex down here with this vertex over here, I do get several points that are inside now, which means that my figure is going to be concave. And there are several different lengths of sides, so that means it has to be irregular. I will also note that if it is a concave figure, it has to be irregular. Okay, let's classify this figure now. There are 5 sides, which makes this a pentagon. It does cave in, point C, therefore it's concave. And since it's concave, it has to be irregular as well. For this figure here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, which means it's a nonagon. It does not cave in, so it is convex. And if you'll notice the markings, all the sides have the same length and all the angles are the same measure. Therefore, we would consider this regular. Most of you know a stop sign is in the shape of an octagon. It is convex, it does not cave in anywhere, and all the sides and angles are equal. Now we don't know that for certain based on this figure, but it is designed that way, so we would consider this regular. This is a four-sided figure, therefore we would consider it a quadrilateral. It is convex, and it is also regular. This figure here trips up a lot of people. A lot of people say it is a triangle. However, if you count the number of sides, we have 1, 2, 3, 4, 5, 6 sides. Therefore, this figure is a hexagon. It does not cave in either, so it is convex, but it is irregular because not all the sides and not all the angles are congruent.